Good evening, everyone, and welcome to the Parsippany Library as we present Meatless Mondays. Our presenters today are Anika, Arora, and Divya, Arora. Just some Zoom etiquette. If you could just keep yourself muted. If you have any questions, you can put them in the chat or write them down, and we'll ask them at the end of the presentation. Welcome, Anika and Divya, and it's all yours.
Hello, my name is Divya and I'm a 7th grader at Brooklawn Middle School.
My name is Anika and I am a 9th grader at Parsippany Hills High School. We are here to propose our Meatless Mondays initiative to the community. So we're going to start with the basics. What exactly is climate change? So first, sunlight reaches Earth, then some energy is reflected back, some is absorbed and radiated as heat, and most is absorbed by gases to warm the Earth. Excessive gases, such as greenhouse gases, including carbon dioxide and methane, can take too much heat, causing climate change. So here's a video explaining what exactly climate change is.
The Earth and the Moon are basically the same distance from the Sun, yet temperatures on the Moon average an unlivable -18 degrees Celsius. And even deadlier, they range from -170 Celsius during lunar night to 100 Celsius at lunar noon, regularly exceeding both the coldest and hottest temperatures ever recorded on Earth. And while the days and nights on the Moon are about 14 times longer than those on Earth, our planet's relatively fast rotation isn't what spares us from those loony temperatures. What protects us is our atmosphere. By day, it serves as a shield, blocking out the most harmful and energetic of the sun's rays and about 1/3 of the less intense but visible light. At the same time, it traps the infrared radiation, aka heat, radiating out from Earth's sun-warmed surface, keeping us from freezing solid at night. In order for our atmosphere to absorb any kind of radiation, it needs to have some electrically charged particles for passing electromagnetic waves to push around. And most of our atmosphere is made up of gas molecules that don't have an electric charge. They all have a balanced number of positive protons and negative electrons. But some molecules hold most of their negatively charged electrons closer to one side, lending them a lopsidedness that can jiggle back and forth to absorb the energy of incoming infrared rays. For example, water, ozone, and nitrous oxide are all electrically lopsided, so they all absorb infrared radiation. Then there are gases like carbon dioxide and methane. On paper, neither molecule looks lopsided, so it doesn't seem like they should be able to absorb any radiating heat. But in reality, gas molecules aren't motionless. They crash into each other billions of times per second, knocking each other in different directions and also into different modes of rotation and vibration. And it turns out that both carbon dioxide and methane spend most of their time shaking it in electrically lopsided ways, allowing them to absorb infrared rays and help insulate the Earth. Even though many different kinds of molecules can absorb infrared radiation, the vast majority of our atmosphere can't, because it's made of nitrogen and oxygen, which don't get lopsided even when they are vibrating. They're too symmetric. Nevertheless, the lopsided 1% are such good infrared absorbers that they manage to intercept about 90% of Earth's outgoing heat. Each captured ray gets pinged around the atmosphere, and most end up returning to the surface at least once before escaping to space. We don't need to visit the Moon during frigid lunar night to know just how important the game of radiation pinball is for Earth. Ice records from our own coldest climate show that small natural variations in atmospheric carbon dioxide produce relatively big changes in temperature. They also show that, compared to the last 800,000 years, the game today is much, much harder. Thanks so much. The Earth and
So 51 billion tons of greenhouse gases are added to the atmosphere every year.
So how does climate change even impact us? Well, for starters, as the global climate increases, seawater is expanding and glaciers are melting, and both of these factors are causing a rise in sea level. Weather events are becoming much more intense and starting to happen much more frequently. There's increased precipitation, which is pretty simple to understand because the more heat there is means there's more evaporation, which means more precipitation. The last thing I'll be talking about is risks to nature. Climate change is hurting many animals and plants because it is harder for them to adapt to a higher temperature. Here are some examples of those impacts around us. There were hurricanes in Puerto Rico, and they're happening all over the US a lot more now. There were forest fires in California, rising sea levels, and melting glaciers. An interesting fact that we learned is that in the beginning of this year, there was a glacier in Antarctica which broke off, and it was larger than the size of New York City. So that shows how serious this issue is. Here is a picture of weather and climate disasters all over the US. There are droughts, forest fires, tornadoes, hurricanes, floods, and these events are becoming much more intense. So here is the greenhouse effect in a nutshell. This picture shows many important facts about climate change, such as 2016 to 2020 was set to be the warmest 5-year period on record, and global fossil CO2 emissions rose by 62% from 1990 to 2019. The fact that we are going to be focusing on today is that consumption patterns have to change in order for us to support climate action.
So where are greenhouse gases emitted from? So a large portion is from electricity and heat. Industries, transportation, buildings, and food waste all also have pretty big contributions. And agriculture and land has the second largest impact on climate change, and we're going to be focusing on that today. So here we see the greenhouse gas emissions from the agricultural industry. So there's deforestation. So when trees are cut down to make cattle farms and for growing crops, there's less absorption of carbon dioxide. Soil respiration, which is less trees, the soil thaws and releases methane, which is a greenhouse gas. Fertilizers, so excessive amount release greenhouse gases and cause eutrophication. And what that is when too many nutrients are in water due to runoff from the land, causing too much plant life in water and death of animals due to lack of oxygen. So that sounds really complicated, but it's pretty much when the runoff gets the fertilizer and that's harming the plants and animals in the water. So then there's littering and manure, which is straightforward, and it releases greenhouse gases. There's fires, which is also bad for habitats, pollutes the air and bad for our health. And then there's livestock, and that's what we're going to be looking into. So this graph depicts the carbon dioxide footprint in terms of kilograms of carbon emitted during the production of food categories. So as you can see, the beef industry has one of the highest footprints across many different food groups. So here's a video explaining how beef is bad for the climate.
Thanks to the funders of Peril and Promise for supporting PBS Digital Studios.
Beef, it's what's for dinner. Or, depending on who you ask, it's destroying the planet. This meat is contentious. Lots of people love eating beef, but it also has the biggest environmental impact of nearly any food we eat. So what can we do about it? Per pound, producing beef releases more greenhouse gases into the atmosphere than just about any other meat. That's mostly due to methane, which has about 25 times more global warming impact than the same amount of carbon dioxide. Cows produce a lot of methane. Well, actually, all cattle do. Cows are female cattle who have had babies, while most beef comes from castrated males called steers. I'm using cow to mean four-legged farm animal that moves. Most cow methane comes from their mouths and not, the other end. See, cows have a weird multi-chambered stomach. In the first part, called the rumen, microbes break down fibery plants like grass and give off methane as a byproduct. Today, there are 1.4 billion cows walking around belching methane. They're responsible for nearly a tenth of all human-related emissions. Some of that's from dairy cows, but most of it comes from cows raised for their beef. I don't know if you've ever seen a cow up close, but they're massive. It takes a lot of cow food to make that much cow, and a lot of land to make all that cow food. More than a quarter of all land on Earth is devoted to feeding those cows. As a result, beef is one of the top drivers of deforestation, which is mainly happening in tropical forests, some of Earth's most biologically diverse ecosystems. Left to their own devices, trees are carbon-trapping wizards. They pull CO2 out of the air and transform it into wood, which locks carbon out of the atmosphere for a long time. Cutting down trees means they stop taking in CO2, and as trees break down, their carbon makes its way back into the atmosphere. Having too many cows on a piece of land can also cause the soil to break down and release trapped carbon into the air. Methane emissions, deforestation, and degradation of soil, these are just the big players. Our collective love of beef creates a whole pile of other environmental, climate, and health impacts. So altogether, there's a lot of bad sides to beef. But can we make beef better? One place to start is with all those burping cows. We've been breeding cattle to be more and more efficient at turning their feed into flesh and milk. That helps farmers make more money faster, but has the added benefit of slightly reducing a cow's carbon footprint, because the faster it becomes beef, the less time it spends burping. If your main concern is climate and you want to keep eating beef, then you may want to choose feedlot over grass-fed beef. That's because cows grow faster and reach slaughter weight more quickly on grains, and again, the faster they become beef, the less time they spend burping. Farming grains to feed cows creates emissions too, but the cow's shorter life makes up for those extra greenhouse gases. On the other hand, feedlots come with other environmental and ethical questions too, but that's a whole nother conversation. One alternative that's catching on is silvopasture, which is basically raising cattle and trees on the same land. The trees pull carbon from the atmosphere, which can help offset some of the methane from the cows. Turns out, trees are pretty good for the planet. Who would have thought? Whatever the cows are eating and wherever they're living, they're still cows and still methane-making machines. So to meaningfully reduce emissions from cattle production, we need fewer cows, and that means less beef. There's no magical technology or farming practice that will have anywhere near as much impact as eating less beef. But before we start a food fight, it's worth noting that in some places, we're already cutting back. Since the 1970s, beef consumption in the US has gone down. Some of this might be due to the fact that we're eating more chicken, which from a climate perspective is a helpful switch, since chicken causes way less emissions than beef. We can also replace beef with things that aren't meat, like beans, mushrooms, those fancy fake meats everyone is talking about, or like a vegetable. Like most climate issues, what you do as one person may feel pretty small, but collectively, many individual actions together do move the invisible hand of larger change. And if you want to put on your activist hat, you can do things like email your school or office to ask about Meatless Mondays, ask your favorite restaurant if they can make more non-cow options, or be one of those people on Instagram who tells everyone about that really good mushroom burger recipe they have. Seriously, I have a really good mushroom burger recipe. So even if beef is what's for dinner tonight, who knows what will be on our plates tomorrow?
Funding for this episode.
So this slide is pretty much a recap of the video. So this picture shows how much energy it takes to make a 1/3 pound burger. So this requires 600 gallons of water, 64.5 feet squared of land, produces 0.126 pounds of methane, and a total carbon footprint is 4 pounds. So below you can see the general process of producing a beef patty. So you need water, land to make feed, corns, beans, water for the cows to eat and drink. They release greenhouse gases, then there's transportation, the slaughterhouse, refrigeration, and transportation again. So there's many steps to the process. And one of the steps that contributes most to climate change is how they release greenhouse gases. So cows release methane, and methane absorbs 25 times more heat than carbon. And microbes in the cow's stomach break down cattle feed into useful energy, which produces methane.
Okay, so now we are going to be comparing a meat burger meal to other vegetarian and vegan meal options. The first one is a bacon cheeseburger with oven fried potatoes. And through the production of making this, the amount of CO2 released is about 7.44 kilograms of carbon. And you can already see that this is a very large one. The next meal is a vegetarian omelette with buttered toast and orange juice. Through the production of this meal, only 1.69 kilograms of carbon are released. So already you can see how big of a difference there is. The production of making a vegan wood double uses about 0.759 kilograms of CO2, which is also a very low amount. And the lowest is going to be the peanut butter and banana sandwich, which produces 0.36 kilograms of carbon. So you can see that the meat burger option has a much larger production compared to these. So just by skipping one day in the week can make a very big difference. Putting this more into perspective, these are some interesting facts that we found. One is that 348 miles driven is the amount of emissions we could save if you ate just one less serving of beef every Monday in a year. So this isn't even following Meatless Mondays, it's just one less serving of beef. The other fact is that if the world ate 15% less meat, which is basically following Meatless Mondays, it would be like taking 240 million cars off the road each year, which again puts into perspective how big of a difference we can make. Here's just an example to help you understand further how big of an impact we could make. The example is if Meatless Mondays were enforced in the Parsippany Troy Hill School District. Let's say there's about 7,200 students and about 1,000 meat lunches are bought each day. This is just a random example. With the information that the carbon footprint of a meat burger is 4 pounds, by doing the math, you can see that 4,000 pounds of carbon can be saved every Monday. And based on how many Mondays are in the year, we could save up to 102,000 pounds of carbon. This is for the total school year. So you can see that a lot of famous people are participating in Meatless Mondays and are encouraging it, such as Oprah, Paul McCartney, and Bill Gates. Many schools are participating in Meatless Mondays around the world and many hospitals too. So Parsippany, if others did it, why can't we?
So coming back to our proposal, we want to encourage everyone to eat meatless meals every Monday, and we think this small sacrifice can make a big difference for the environment. Thank you for watching.
Do you have any questions?
Pat or Laura, do you have any questions for these two young women?
I have a little one. In general, first of all, I just have to say it's an absolutely excellent presentation. I appreciate so much your sharing. It's almost more facts than I can take in, even though I thought I knew a lot. It still was a lot. There was one little thing though. You mentioned something about the lockdown during the extreme COVID lockdown, and you said that didn't seem to make much of a difference in greenhouse emissions with regard to cars. I don't know where that data came from, because it seemed to me that people were using less gas and getting out less.
Well, I mean, now there's like the production of masks. I think that probably has an impact on that. Yeah.
Yeah, and
Okay.
People didn't stop eating hamburgers, that's for sure.
No, they didn't do that. And I don't know, but I mean, it seemed to me there were fewer, car miles for a fairly long period of time, several weeks, maybe a couple of months.
Yeah, we could probably go back to that. I had two questions. First of all, this is the third time I'm seeing this, and it's wonderful every time. You guys did such a good job on this presentation. My first question would be, have you gotten a feel at all for what the students in your school feel about this?
Not really. We were thinking about maybe doing some sort of pledge or like a Google form in our school to see how many students support this and would be willing to participate, and that could like help us convince.
And just among your friends, like have you told any of your friends that you're doing this?
We have told some of our friends and they think it's a good idea, so.
That's what I think it's going to be very popular. I really do. Yeah. Everybody likes that they can do something, you know, if you can recycle a plastic bottle or if you can bring your own cloth bag to the supermarket, it really makes you feel better.
It does.
And I do believe that that's going to be a big convincing point for your friends at school. I think that you're going to have a lot of support there. I was just curious if anybody had said anything. And the other issue, the other topic that I had about regarding this, and you guys are probably familiar with the Beyond Burger, the plant-based replacement burgers. They're becoming very popular. And they're coming into a lot of the fast food restaurants and restaurants now, and they're like a really big option for a lot of people. So this is something a lot of people are talking about. It. There's environmental issues. Timing has a lot to do with it. Like if you come up with the right idea at the right time, and you know, I hate to say it, but with all of these storms we've been having, and you know, all the crises with the climate change and stuff, you girls are right in perfect timing with this, which I think is going to be one of the factors, one of the variables that will help you kick off this campaign, and it's going to be very successful. I really believe that. Yeah. Okay, that was for me. Yeah, and I'm so glad that you got to show it to Dr. Sargent. And what I'd like to do is, because I know Mrs. Emler puts the Zoom link on the YouTube channel for the library. And I'll take that link and I'll post it on the Parsippany, Supporting Parsippany Facebook page. You know, the big Parsippany Facebook page.
Yeah.
I'll put the link to this on it with a little blurb about the topic. And I think you'll get a lot of people who will watch it when, you know, just a little more convenient time, and parents will watch it who have kids at Brooklawn and things like that. So is that okay if I do that?
It's okay with me.
For you guys? Yeah. Well, Anika and Divya, I want to make sure that it's okay with you guys, because.
Yeah, that sounds good.
Okay, good. Little
Good.
PR. Yeah, little public relations. Yeah. But it's wonderful. Otherwise, it's fantastic.
Oh, yeah.
Yeah.
That's one of the things I said to both the young ladies when I first saw the beginning of the PowerPoint. I was like, wow, this is really good. So you both should be very proud of yourself. You've done a fine job.
It's a good order. It was easy to follow. Really well done. Yeah. So.
And made plenty of sense.
You girls should think about going into marketing and advertising. Just say, you know, as maybe a sidebar, you know, maybe a side job, but that's what a lot of it is. It's just, you know, convincing people and marketing your idea. It's a big part of it.
I just have a little question. Have you done any, to you young ladies, have you done any surveying of your friends if they eaten any of the things Mrs. McCluskey's mentioning, Beyond Burger or Incredible Burger or whatever, with the meatless burgers, and whether people like them or not? You might be able to find out what substitutes people might have. I mean, obviously, you don't have to eat any kind of burger at all, but you know, they're fill it need.
Well, I don't know anybody who's actually eating one of those. But
yeah, we haven't really talked to people about that as much, but that could be a future step.
Yeah, something interesting. Yeah, there's a lot you can do with this. Yeah,
I agree. Okay. I think that we are at the end of our program. Ladies, would you stop sharing your screen, please?
Sure.
Thank you.
Okay.
Well, there we go. So if we don't have any more questions, I guess we will say thank you very much, Anika and Divya. We appreciate your putting this together and showing it to us. And thank both of you ladies for coming.
Thank you.
Thanks for watching.
And lots of luck with your program. I think it's wonderful. Yeah.
I agree.
Did a good job.
Agree.
Yep. Yeah.
All right. Well, everyone have a safe weekend, and we'll see you on Tuesday.
Okay.
All right.
Thank you.
Good night, everyone.
All right.
Thank you.
Thanks.